In this video, we'll consider generalizations about activating ortho-para directors, as well as generalizations about deactivating meta-directors. Let's begin with activating ortho-para directors. What we've seen so far is that electron donation via induction or resonance activates the ring toward EAS and directs substitution to the ortho and para positions. There are other substituents, though, besides the alkyl and methoxy groups described in parts 1 and 2 of this video series that donate electron density to the ring. Some examples include the amino group, the hydroxyl group, amides, and esters. Note that each of these groups possesses a lone pair of electrons that can be donated to the ring through resonance. Therefore, these groups also activate the ring toward EAS and direct ortho and para. On the other hand, we have deactivating metadirectors. All groups that withdraw electron density from the ring are deactivating, and most such groups will also be metadirectors. Some examples include aldehydes, esters, carboxylic acids, nitriles, the sulfonic acid group, the nitro group, and quaternary ammonium groups. All of these groups, except the quaternary amino group, possess a pi bond into which the ring can donate some of its electron density. Therefore, these groups are electron withdrawing. The quaternary amino group simply possesses a positively charged nitrogen that withdraws electron density powerfully through the inductive effect. All of these groups are not only deactivators, but also metadirectors. To this point, we have seen that The next video in this series will continue our discussion of the effect of substituents on EAS reaction. We'll more closely examine this unusual category of substituents, the halogens, which are deactivating ortho-para directors.